Hello everyone, welcome to the lecture series of pattern classification. I am Kundan Kumar, and if you would like to have these lecture slides, you may refer to my GitHub page at this given link. In this lecture, we will be discussing the clustering algorithm, which is an unsupervised learning technique. So basically, the clustering refers to the process of grouping samples so that the samples are similar within each group, and the group is called clusters. So let us write the definition of clustering. So here, clustering refers to the process of grouping samples so that the samples are similar within each group, and the group are called clusters. Okay, so suppose we have set of samples in the feature space. Okay, okay, so the clustering is the process which will group the samples which having some similar property. Okay, that means in this group all the samples having some similar property, that it has the similar color. Okay, similarly for this cluster. Okay, so similarly for this group, so these groups are called the clusters. Okay, so basically the clustering is the task of dividing the set of data samples into number of groups such that samples in the same group, okay, samples in the same groups are more similar to other data samples in the same group than those in the other groups. That means it will be similar within the group, but it will be dissimilar to the other group. Okay, suppose let us take one example that suppose you are going to a supermarket for shopping, then you can find that the products are organized in groups with similar items, like cloths will be at a single place, suppose spices will be at the single place, or some cosmetic items will be at single place, vegetables will be at single place. That means the basically items are organized in groups with similar property. Okay, so there are many applications like supervised learning that we have already studied. It has the application in marketing, where the clustering algorithm is used to find the group of customers with similar behavior. Okay, then it has application in biology, so that it will classify the plants and animals with based on some characteristics. Okay, it has some application for the clustering of the books, grouping of the books. So the application is in libraries. Okay, it has also application. It also has the application in medical imaging. Okay, where we need to segment the different images, medical images, based on clustering techniques. Then it has the application in data analysis, where we have to analyze the data, and also it has the application in data visualization. Okay, so there are lots of clustering techniques, and they all use different techniques to cluster the data samples. But broadly, they can be classified in three categories. Broadly, clustering can be classified into three categories. First one is partitioning algorithm. Here, this algorithm try to divide the data set, or divide the data samples into predefined number of groups or clusters. Okay, so here the number of clusters is predefined. So for example, the K means clustering. Okay, the next category is hierarchical algorithm. This algorithm does not partition the dataset into clusters in a single step. It takes the multiple steps. So basically it involves multiple steps which run from a single cluster containing all data points to n clusters containing single data points, or vice versa. So you can write it does not partition the data samples into clusters in a single step. Okay, instead it involves multiple steps which run from a single cluster containing all data points on all data samples to an cluster containing single data samples. Okay, or vice versa. That means the n number of clusters containing single data samples, and then in stepwise we will combine those data samples, and at the end we will have a single cluster containing all the data samples. Okay, so when I will show you the example, it will be more clear to you. Okay, then we have the next category is graph based algorithm. Okay, graph based algorithm creates a connected spanning tree and based on some criteria it divides into n number of clusters. Okay, so in the graph based clustering technique, so if we'll take the example of spanning tree, then the graph based clustering, it creates a spanning graph with some weight, and then based on some criteria, then it divides the spanning graph into multiple graphs, and then each individual graph will be treated as a cluster. Okay, so here it will be k number of clusters. Okay, that means it is not necessary that we will have the n number of clusters. Here k will be less than n. Okay, now try to understand these categories using the pictorial representation. Okay, in case of partitioning algorithm, we will have the number of clusters. Okay, and it will partition the feature space based on some similarity, so that each group will have some similar kind of data samples. That means the data samples will have the similar property. Okay, and in case of hierarchical algorithm, it creates tree-like structure. That means some node will be created here, and then it will split into two more nodes or more than that, based on some characteristic or based on some dissimilarity, and it will divide. That means hierarchically it will be divided into the number of clusters. Okay, Suppose this is animal, this is cat, this is dog. Okay, in dog we can have also different varieties, like suppose large dog, small dog. Okay, cat may be categorized to the long hair cat, then you can have short hair cat. Okay, so in this way hierarchically it will be breakdown in each level. Okay, and this process may be in the reverse order as well. Okay, and in case of graph based algorithm, it may create some connected graph with some weights, maybe suppose this is 1.1, 2.3, 4.2 or 1.1. So this type of graph will be created where each node will be our data sample, and then based on uh, some assumption like that, suppose the maximum weighted age. So from here it can be cut down so that we will have the two clusters. Okay. So first we will start with the hierarchical clustering algorithm. So this algorithm refers to a clustering process that organizes the data into large groups which contain smaller groups, and so on. Okay, so this definition also you can understand from this pictorial representation. So here basically this algorithm organizes all the data samples in a large group, that is the animal, and then it contains the smaller groups. Okay, and so on. Okay, so here the hierarchical clustering may be drawn as tree or dendrogram. So whatever the pictorial representation I have shown you, that is called dendrogram. So let us see a dendrogram. That means for a hierarchical clustering representation of the supermarket. Okay, so suppose at the bottom we have toothpaste. Okay, suppose other item we have is toothbrush, soap, towel, rice, or eatable oil. Okay, so at this is at the, suppose this is at the 0 level. Okay, so we can define here level. So this is 0 level. Okay, so here all the data samples are individual clusters. Now, at the level 1, the similar clusters will be combined together. So if you will check all these samples, then you will observe that the toothpaste and toothbrush are very similar to each other. That means if someone will go to supermarket, then they will get the toothpaste and toothbrush in a single stall. Okay, so in the first level, these two will be combined. Okay, so now we have total 5 clusters: 1, 2, 3, 4 and 5. So here this cluster having very close relation to this, that means this cluster is similar to this cluster, but this is not very close to these, because the soap item can be found at the same stall. Okay, so in the next level it will be combined with the very similar item. Okay, then we have 4 clusters. Now which item can be combined, so that we can say that means in the next level which very similar item should be combined. So here this item, if we combine with towel, then towel comes under some different section in the supermarket, but rice and edible items are more similar to each other. That means these two can be found at on the similar stall. So at this third level, this will be combined. Okay, then this is maybe the grocery item. Okay, but this towel doesn't comes under grocery item, so maybe this item will be close to this one. So at the next level it will be combined here. That means at 4th level these items will be combined with the towel. So that means this cluster will be combined with the cluster which is towel. Okay, and at the 5th level these two remaining clusters will be combined. So here we have 6 number of samples, that means n equal to 6. Then number of label is basically n minus 1. Okay, and this is called dendrogram. Okay, this is called dendrogram. Okay, now if we go from bottom to up, then this is called agglomerative clustering, and if we come from top to bottom, then it is called divisive clustering. Okay, so based on this we can divide the hierarchical clustering technique in 2 categories. Okay, so the first one is bottom-up approach, and this bottom-up approach is called agglomerative clustering. Okay, and another approach is top down. Okay, and this is called divisive clustering. Okay, so in this course basically we will cover the bottom up approach, that is called agglomerative clustering. So here we can define the agglomerative clustering as so consider x1, x2, xn are n d-dimensional feature vector. Okay, then we can write the algorithm as so in first step. So this agglomerative clustering is bottom up approach. So at the bottom we have the number of samples. So we will begin with n clusters, where each cluster consisting of one sample. Okay, and then we will repeat step 3 for n minus 1 times, because we have n minus 1 number of labels just that I have shown to you. And then we have to find the most similar clusters Ci and Cj, then merge Ci and Cj into one cluster. That means if Ci and Cj are the most similar cluster, then we will merge these two. And if there is a tie, that means if we are computing some similarity between these two clusters, then if the numerical value will tie, then we will merge the first pair found. Okay, but here how we can find the most similar clusters? Okay, so based on that means the different similarity that can be used with the agglomerative clustering, we can have the 3 different algorithms, that is called single linkage algorithm, complete linkage algorithm, and average linkage algorithm. So we will see one by one. Okay, but for now I can note down here that it has the 3 different linkage algorithm to compute the similarity, and those algorithms are single linkage algorithm, complete linkage algorithm, and average linkage algorithm. Okay, this much for this lecture. Thank you.